The next thing that we talked about in chapter 8 was multiplying and dividing rational expressions, and then also adding and subtracting rational expressions. So I'm going to talk to you about two examples. Here's the first one. I'm going to divide, and it's going to be similar to multiplication, except I thought the division would be a good one to show. So I'm going to divide x squared plus 12x plus 32 over x squared plus 13x plus 40 divided by x squared plus 4x all over x squared plus 10x plus 25. So the first thing I'm going to do is I'm going to copy, change, flip. That's my rule for dividing fractions. And then I'm going to have something that looks just like multiplying fractions. So I copy my first term, I change to multiplication, and then I flip my second term. Now, this is going to be a lot. If I'm going to distribute all this out, it's going to start looking really crazy really fast. So my strategy is going to be to factor first and see if I can cancel anything. So let me factor x squared plus 12x plus 32. Let's see. X times x will give me x squared. Let's see. 4 and 8 will multiply to 32 and add to 12. X times x will give me x squared. 5 and 8 will multiply to 40 and add to 13. Let's see. 5 times 5 will be 25, and that'll add up to 10. And in my denominator, I only have two terms, and it looks like a GCF situation. I have an x in common, so I'll pull that out front, factor it out. All right, so now I'm going to think about canceling. So here we go. Numerator, denominator. X plus 8 over x plus 8. X plus 4s, and only one x plus 5. All right, all I'm left with is x plus 5 over x. So I'm going to write my final answer as x plus 5 over x. Now, a lot of people make the mistake. They think that they can cancel the x's, but that's really illegal math. You cannot do that. It messes up with order of operations. X plus 5 is one factor and x is a different factor, and I can't just kill off the x's there. All right, let's look at the next example. We're going to add and subtract rational expressions, and this idea is slightly more complicated than multiplying and dividing because I have to have common denominators. So when I have to find common denominators, the first thing I'm going to do is I'm going to factor my denominators so I can really see what I'm working with. Okay. So I'm going to factor y squared minus 3y plus 2. Let's see what that gives me. Y minus 1 and minus 2. And then, that's a difference of squares, so y plus 1 and y minus 1. Alright, so now I can see that I have three different factors that I'm dealing with. I have y minus 1, y minus 2, and y plus 1. Both terms have the y minus 1 factor in common, and I don't need to repeat. So let's set up my problem with my common denominator. So I just found out that my common denominator is going to be y minus 1 times y minus 2 times y plus 1. If I compare this denominator here to this one here, I can see that the thing that's different is this y plus 1. And I'm not allowed just to throw in a y plus 1. I'm going to have to compensate for that by also multiplying by y plus 1 in the numerator. And the 3 was there originally. Let's look at the second term. If I look at the second term, the thing that's new is the y minus 2. See, there's no y minus 2 here. So I'm going to have to compensate for that by also multiplying by y minus 2 in the numerator. And there was a 7 originally. Okay? So now I have common denominators. A tempting mistake is to cancel at this step, But then if I canceled, I wouldn't have common denominators anymore. So that's just undoing all my hard work. So I'm going to resist the temptation to cancel right now. And I'm going to distribute and add. So what does that look like? I'm going to go like this, and like this, and let's see. So I get 3y plus 3 plus 7y minus 14 all over y minus 1 times y minus 2 times y plus 1. Let's combine like terms. 3y and 7y, that's 10y. 3 minus 14, that's minus 11. At this point, if there's anything you can cancel, you can go ahead and do that, but it doesn't look like that's the case in this problem. So I'm going to leave my final answer as 10y minus 11 over y minus 1 times y minus 2 times y plus 1.